Good morning class. Today we will start with our new class of chapter mensuration. Okay, and here we will be dealing the left numerical of exercise 18.1. Okay, so yesterday we have discussed in the video till question number 4 and the rest of the question we have given you in the form of a PDF. Today we will be discussing some more numerical of this particular exercise. Okay, so let us start with question number 6. This question is not there in PDF, so you can just understand this question from the video and then you can solve it in a copy. So in this question number 6, we have three figures. One is of semicircle, the other one is in the form of a rectangle with one semicircle part, the other one is in a form of a part of a or a fraction of a circle. Okay, now it is said that through all the figure, through all the parts, an ant is moving. Okay, now we have to tell through which figure the ant has covered the maximum portion or the maximum distance. So we know it, in order to calculate the distance, we always calculate the perimeter. Now the first part, we have a semicircle. So what the easiest way we can have, can you see in the semicircle, 2.8 centimeter is given as the diameter. So first of all, what we can do, we can calculate the radius. So the radius will be the half of the diameter, that is 1.4 centimeter. Now, what is the distance traveled by the ant through this figure? These distance, this length plus this curve part. Okay, so the distance or the perimeter can be calculated of semicircle. Okay, can be calculated by the formula. This curved part is pi r plus this part is d, diameter. We know that the value of pi is 22 by 7, r is 1.4 and d here is 2.8. Now if I cancel, we will get 0.2. This will give you 4.4 plus 2.8, which will be equal to 7.2 centimeter. So this is the distance travelled by the ant while it is travelling through a semicircle. Now, let us take the figure second. Let us take the case of the second figure. Here, can you see? This is in the form of a rectangle. If this is 1.5, this will be also 1.5. This whole is 2.8, so obviously this will be 2.8. So first we will calculate the distance travelled by the ant in these straight lines. So the distance will be equal to 1.5 plus 1.5, these two lines, that will give you 3 centimeter. Okay, this is 2.8. So along with these two distance, we can also add 2.8 centimeter. This will give you 5.8 centimeter. Okay. Now, let us calculate of this curve part. Again, only the curve part the ant has travelled, and that is equal to pi r. Again here, radius will be 1.4, so that will give you 4.4. Okay. Now, what is the total distance travelled? So the total distance travelled by the ant will be 5.8 plus 4.4, that will give you 10.2 centimeter. Okay, this is the distance travelled by the ant in travelling the figure B. Now let us go for this third figure. Can you see these two lines? So the ant will go through these two lines. So each line measured 2 centimeters. So what will be the total distance travelled by the ant while covering these two lines? So this is This will be equal to 4 centimeter. Alright. And this curved part, again the same as in this figure. So in this figure what we have calculated the distance of the curved part 4.4. Here also the distance will be 4.4. Now we will add these two distance and we will get it here 8.4 centimeter. Now in figure first the distance covered was 7.2. In figure B the distance covered is 10.2. In figure C the distance covered is 8.4. So in which figure the ant has traveled the maximum distance? So obviously through figure B. Okay. So in all of these three figures, in order to calculate the distance which is traveled by the ant, we have to calculate the perimeter. I hope it is clear. Now let us move to our next question, that is question number 11. Now let us come to question number 11. In question number 11 we have a figure in which this triangle form of figure is made, and that is the shaded part. So we have to calculate the area of this particular shaded part. For this what we have to calculate is, what we can do is, from this area of the entire rectangle, if we divide these unshaded, if we subtract this unshaded, the second unshaded and the third unshaded one, then we can calculate the area of the shaded portion. So first of all what we are going to do, we are going to calculate the area of the rectangle. So what is the area of the rectangle? That is length into breadth, obviously. So what is length here? Length is 18, breadth is 12. So 18 into 12, and that will give you 216 centimeter square. Okay. Now this was the area of rectangle. Now what we can do? We can consider this first figure, unshaded one. Okay. Now this is given that the distance of this is 10 centimeter. Dear, in the book it is mentioned 100, but please to correct it, it is 10 centimeter. Now this is in the form of a right angle triangle. Okay. Now area of figure 1. So what is the area of the triangle, half into base into height. So half into base, either we can take 12 or 10, it's up to you. So half into, I am taking 10 here, and height. So this will be 60 centimeters square. First unshaded. Now the area of second figure. This one is also in the form of a triangle. Okay. Now this is given as 7 centimeter. So again half into base, I consider it as 18 and as 7. So this will be 63 centimeter square. Now let us go for area of third figure. Area of third figure, this one, this is again in the form of a triangle. Now see, if total length is 18 and this much part is 10, what is the left distance there? 8. If the total length is 12, the left part is 7, what is the remaining one? 5 centimeter. So the area will be half into base, either we take it as 5 or 8 into 5. So this will be 20 centimeter. Now what we can do? We can add all these three figures. So what will the total area? Area of unshaded part, which is not shaded. Unshaded part. 60, 63 and 20. So this will give you what? 3 and 6, 12. So that will be equal to 143 centimeter square. Okay. Now this is the area of unshaded figure. The whole area of rectangle we have got. Now how can we calculate area of shaded figure? Now area of shaded figure. Now in order to calculate area of shaded figure, from the overall rectangular area, we can subtract the total unshaded area. So we can get shaded area. So that will be equal to 3 and 73 centimeter square. I hope this particular question is clear. What we have done is, first we have calculated the area of the rectangle, and then we have calculated the 3 unshaded figures area, and then in order to calculate this shaded area, we have subtracted the unshaded area from the area of rectangle. I hope the question is clear. Now let us move to the last question of today's class, that's question number 12. Now let us move to question number 12. In the question is given, ABCD is a square lawn of area 729 meters square. This figure, the inside figure, okay, area of ABCD. Now area of a square ABCD is given as what? It is given to be 729 meter square. So now how we are going to calculate the side? So we know that area is side square, so side can be calculated by square root of 729, and the square root of 729 will come out to be 27 meter. Okay, so this is the side of the small square. Now it is given that a path is there. Can you see this left one? This is the path. This hole is the path. This is the path which is running all around the square. The area of the path is given. Area of the path is given. It is equal to 295 meter square. Okay, so we have area of this small square plus area of the path. So if we add both the area, we will get the area of the bigger square, which is outside. Okay, so area of bigger square, that is equal to 729 plus 295. Okay, this bigger square has enclosed this square lawn plus the path. Okay, so that comes out to be 1024 meters square. Area of bigger square. So we can easily find out the side. 1024 square root of it, and this will come out to be 32 meter. So this is what we have to do. First, we have taken the area of the smaller square, then plus area of path. We have added them both and we got the area of the bigger square. And from that area which we have calculated, we have calculated the side. In fact, the side of the smaller also and the side of the bigger also. Now what it is asking in first part, what you have to do is, in first part you have to calculate the length of the boundary of the square field. The length of the boundary means what you have to do? Perimeter. So this is square, bigger field it is asking. So what will be the perimeter of the square? Obviously 4 into side. And the side of the bigger one is 32. So this will come out to be 128 meter. Alright, this comes out to be 128 meter. Now, in second part, what it is asking? The width of the path. Can you see this spiral one, the middle one? This is the path which is unshaded. This is the path which is running around the square. We have to find the width. Width means this we have to find. This width. कितनी उस path की चौड़ाई है? Width we have to find. Now, can you see in the figure if I show you? So, let us say that the width of the path is x. Let us say the width of the path is x. So, this is also x and this is also x. क्योंकि जो path है that is of equal width and is running around the square. So, if I have calculated it as 32, so can I write x plus x, that means 32 equal to 2x plus this side which comes out to be 27. So 32 minus 27 will give you 2x. 5 is equals to 2x, so x is equals to 5 by 2, which will come out to be 2.5 meter. And hence 2.5 meter is only the width of the path. I hope these numericals are clear, and I request you to solve these three numericals which we have discussed today in copy. Please try to understand from the video and then do solve it in a copy. So here we are ending our exercise 18.1. Thank you.